Hi, my name is Young, and today we're going to cover the second design pattern, which is the observer pattern, right? So what is it? It is a behavior design pattern and define one-to-many dependencies between objects. Okay, so let's jump right in to see what it does and how do we apply it into our programs, right? So the observer pattern, let's look at the formal definitions of it. The observer pattern defines a one-to-many dependency between objects. So when one object changes state, all its dependents are notified and updated automatically. So that is the one-to-many relationship. If you look at the diagram here, we have a subject object. So this subject object has an internal state, which is this cup here, hold an integer. So when the internal state is changed, which is, I put the number 8 in here, it will automatically update all the other objects here, which is subscribed to this subject object. So it is similar to the MQTT protocol we've learned, that is a publish subscribe models. And this subject object is gonna publish some of the informations when it is updated to the observed objects, like inside right here. Yeah. So let's see the design principle behind the observer patterns. You get the idea, right? So the, des the design principle we're going to encounter here is strive for loosely coupled designs between objects that interact. What is a loosely coupled design? So here you can see the subject object doesn't know much about these objects, these internal states. It only knows that, okay, I have a new updated values and I want all of you to know that. And how would you use that information for? It is your business. It is not mine. So these two objects is independent of each other's, and that is how we define loose coupling. So observer pattern is all about loose coupling. That the subjects and the observers are independent of each other's, and they know just a little about each other's, but not like the whole machines operating inside of that interface or that objects. Right, so as you can see here, this is a loose coupling. We have an interface subject, we have an interface observer, which it is loosely coupled with each other's. And when we implement it, yeah, we have register observer for putting the new objects into these regions right here. Remove to get one out, and we have the notified observer, which is the functions that send out the message to the observers when the code is updated, right? So, so in the observer, we have the update to get the updated values from the subjects. Okay, so that is strive for loosely coupled design between objects that interacts with each other. But now let's rethink about the three previous design principles that we've learned. That is, encapsulate what varies. So if we would look at this, the things that change in this, it is the internal state of the subjects, right? So the subjects here have the internal state will change. This one is varies, and we need to encapsulate it. Yes, we did it. We've done it. And this is for the example, but I will talk about that later, right? So another principle is program to an interface, not an implementation. We already did here. We have an interface for the subjects, an interface for observer that define these, right? So when we implement these objects, yeah, it is more flexible, it is loosely coupled, and we have favor compositions over inheritance. So if you would look at this, the subject object, it has, like it has a, you remember the has a relationship. So subject object has four observers. It is composed of these four objects, right? And it will changes all these. So it is the favor compositions over inheritance because there are no inheritance appeared in this scheme, right? Because it's a subscribe and publish and subscribe models, right? It is a composition. And so we've covered the design principles for the observer pattern, but how do we implement it in our real application? So we have an example of the weather monitoring application where we have our weather data is updated by you know uh, uh, by a host, right? It get updated, it is varies, and all of these display. It depends on the data, right? So we will implement a weather data from the subject, which will notify all of the changes, like the temperature, the humidities, and the pressure, to all of these display, to all of these observer. So if the display, all of these display, subscribe to the weather data, when the weather data changes, as so the display will be notified and then will change accordingly. That is how this observer pattern work, which is this subject object is our weather data. It has the internal state, that is the humidity, temperature, and such. It would change. And when it change, all the other subscribed objects here, the observers, is going to change. In our case, it is a display uh, element. Display objects will change based on the data. And how do we implement that? Let's look at our code. So after it's imported all the necessary libraries, we will create an interface server. I will put it here. Yeah, easier to see. As you can see here, we have our interface subject. No, observer first. Interface observer, which has only update, with all these parameters. So and we have our subjects, which implements all of these virtual function. Right? And let's now implement the weather data. So weather data consists of all the observers, which are saved in a vector in all of their data, their internal states. So what do we have? Our functions here. We registered our observer by adding it into our list, into our observers list, pushback. And we can remove it if the observer would like to unsubscribe or opt out of these notification. So we will erase it out of our list. And we also have another functions for notified observer, which is sending out the update, right? So we're gonna call the update. We're gonna call the update of our observer. We're gonna call that because the observer here, they have their own update functions and methods. So when we have some change, we will notify it, okay, you need to update these new informations. And that is when we put all of these parameters in, it will be sent into that. It will be sent into these objects, the object O, for objects in our observers, right? Okay, and so we have our functions measurement change. So when it's changed, it's gonna notify the observers. We can, kind of like implement many other functions here, but you get the idea. When the measurement changed, it's gonna notify the observers, right? So here is one example where we set our measurements for all of these values. It is changing the internal state of the object weather data, right? And so it is changed. It will call the measurement changed, and it will notify of our observers. Now let's implement our current conditional display, which is an observer, right? So an observer, it will inherit from our interface observer and our interface display elements, just for the whole purpose of displaying, right? We have our internal state, which only display the temperature and humidities. We don't display pressure here. And we have our weather data. We saved it here because when we want to unsubscribe, we will use this data to unsubscribe from our display class. So when we create new object, I will create an object that is linked, that is subscribed, that is registered to our weather data. So we're going to save this weather data into the pointer weather data, and also we're going to register it ourselves in our weather data. So we establish the connection between the two, and we implement our update function here by, it's gonna get the temperature of this current conditional display, the values of these. It's gonna be updated through the update method, and it's gonna display it out, right? So let's see our code running. As you can see here, I create a new weather data that is our subject. I created our observer, which is the observer, the display. And when we initialize the display with our weather data, it's gonna register this, which is the object, this object here, the object current display. It's gonna register observer, in which it's gonna push into the list of observers in the weather data object in here. So currently, if you so the weather data, when it set the measurement for the weather data, which is updated our values, it's gonna change first. It's gonna change the internal state of our weather data. It's gonna change the internal state of our weather data. Then it's gonna call that, okay, we have our measurement changed. So it will notify all of our observers, which in this case we only have one observers. But if we implement more, current, we implement another class for display, like statics display or forecast display, you get the idea. Then it will notify all of that because it will go through all of the observers and call the update methods in each one of them. And so that is how our programs work. Right, so let's go back, continue our um, design pattern. So, well, actually, if you would look at this, this is followed the push model, which is our subject sent out the details when a change occurred, which as you see here, we have our weather app. So the weather app push model here, we are pushing when this is when we're pushing because the update, it is passed all of these values from our weather data, right? It is push out. But with our pull model, we'll create more flexible. It will give it more flexibles and more control over our data. Because what if we want to add another metrics, like it is not temperature, I want to add um, the time of a day that it's gonna rain, or any sort of other attributes, right? So I would have to update this all again, right? No, we're gonna apply all of our object-oriented principles by using the pull model. which I'm showing here. So we have our object, right? Instead of we update with parameters, we're gonna call it without parameters to the observer. It is equivalent to, okay, we have our info updated. Please come to get it by yourself. If you want something, just get it by yourself. So by that, we're gonna implement our update in our observer and, and utilize the getter methods to take what the observer needs. If I need the humidity, I will take it. I will use the get humidities to get that attribute from the object. If I need new informations, I know that I have another attributes from the objects. I will use a getter to do that job for me. But the idea is the objects only notify that, okay, you should come and get by yourself. I'm not telling you any of these informations. That is the core idea of our pool models when we want to when we want to elevate our codes into further, right? So here we can create our update in our notified observers that without parameters here. And then we're gonna implement the update method in the observer class. So we're gonna use the getter methods to get what we want. And that is the core idea of generalize with a pooling model. So let's continue to our Lambda expression. So we've learned that, okay, all of these are objects, but there's another quicker way and not more efficient, but more concise way to describe it. That is using a Lambda expression. Lambda expression is like getting the functions and saved it into a variable. Here I have auto keyword, which will automatically define the data type of this return. So basically, it saved the function. It saved this whole function, this function of return x plus y into my lambda. So when I call it, I don't have to define a function with a name or a class of my class, right? Just to add something. So that is the key idea of Lambda expression, and this can be used to implement our observer pattern. As you can see here, we have our Lambda expression. We have our current display, and it's gonna get the temperature and get the humidities, then display it out. And we're gonna add this function, add this Lambda expression into our observers list. So when we want to notify, we will call it out. We will call the Lambda to do that for us. And this can be done outside of the class, right? We can only have this, and we're gonna do some of the subscribed, we're gonna add this Lambda function into our observers list. And that is how we implement our Lambda expression with observer pattern. Sorry, the other way. So you get the idea. And if you've come to this point, congratulations, you've learned about the observer patterns. And yeah, that is the end.